Hello guys, I'm back with a new video for you. Today's topic is about SQL injection. Some of you might know what it is, but some of you might not. So, to define SQL injection, I would say it is a web application vulnerability which allows you to change the logic of an SQL query executed on the server by altering the input you provide to it. This is done to obtain unauthorized access to restricted info. I have written an article about this. The link is in the description. You can check it for more information about it. Today I want to focus more on the demo. So let's get to action. I have two examples I want to show you today. The first one is this login portal. This is a simple page, username, password field, to log in. On the database server, I have created 3 users. Let's go to my Ubuntu server and see them. Okay, we have this one here. So let's first use okay, and let's select the info from users table. Users. Okay, 3 users here: user 1, user 2, user 3. Password for each of them. No need for secure password for this example. Now let's get back to the login portal on my attacker machine, and let's see how we can use SQL injection. Okay, we saw those users. Let's try first to use user 1 and bad password, incorrect password. Let's say random pass. Log in. Okay, username or password is incorrect. Going back, I'm going to use user 1 again and put password. Logged in. Okay, we managed to log in. It says here, welcome user 1. I also added the statement executed behind, so it's easier for you to understand. So we have here user 1 for username, the user we typed in that field, and the password. Now, in order to break this statement and modify the input in order to alter to change the logic executed behind, we must see first where we can modify the input. So we see we have here the select all from where username equals. This one cannot be changed. We can change only this one here and this one here. So our changes will be on this part. Now we are going to change first for the password and use a payload in order to log in with the user that actually doesn't exist. So I'm going to log out. I'm going to put the user hacker, and then for password I'm going to put random. I hope I'm not giving the right incorrect payload. Let's see if I get it. Okay, I got it. So it says welcome hacker. Hacker user doesn't exist. You saw it was only user 1, user 2, and user 3, but somehow I managed to log in. Now let's have a look on the executed statement. Select all from users where username equals hacker and password is random or 1 equals 1. Let's analyze this statement and understand why we managed to log in. First of all, we have this password here, the one that I highlighted, because this is the point where I actually modify the input. So we put a random password, we put a user that doesn't exist. Normally we shouldn't have any line returned from the database because this user doesn't exist. But we have this or 1 equals 1 here. 1 equals 1 is always true. And when we have a condition here, this one, it doesn't matter if it is false or true, because false or true in the logic operations is always true. So this statement will always be true, and the whole select statement will return the whole list of users and passwords. So if there isn't any other filter that verifies the count, the row count for this select statement, for instance, to check that it returns only one row that would match for a specific user, this happens, and everything here after the two dashes is treated as a comment. So this part is actually ignored by the server. Only this part is executed. Let's log out and try again, this time for the user. So we have user hacker. So we are going to close the single quote and then use again this or one equals one statement, and then use a double dash and a single quote to let's say ignore comment the rest of the statement in order to be ignored. And for password, I don't know, it doesn't matter. I'm going to put again random, but you can type anything, it won't matter. If we go back to login, we see now it says welcome hacker. We have this whole payload here set as user, and the executed statement changed to select all from users where username equals hacker or one equals one, and this whole part is ignored. So the executed statement on the server is actually this one. So we have username equals hacker. This is false. We don't have a hacker username in the users table, but one equals one is always true. So we have here false, we have here true. False or true is always true. So this statement will be interpreted as true because it returns the lines. Also, it depends on the logic behind, on filters, so on. But this is the most basic vulnerable example for SQL injection. So we managed to log in. Of course, there's a lot of guessing game and trial and error in SQL injection, because normally you don't know the syntax that is used behind. You can guess it, or I don't know, think about it and try to change based on what you think is executed behind the server. I will change a bit on the server side the syntax in order to let you see how this affects the payload. So I'm going to log out and going back to the Ubuntu server. Okay, we have this page here, validate login.php, and here is the statement that is executed behind the web interface, to say so. We have select all from users where username equals username and password equals password variable, the one that we already saw on the page. If we change here and put where username equals the variable that holds the username between brackets, and for the password we do the same thing, and we save. Now we are going back to my attacker machine and try again the same payload used. It shouldn't work anymore, and we will see how we can change it in order to make it work based on the new statement from this validate login PHP page. Okay, back to the original page. So let's try again. We had hacker and this single quote one equals one, and then the double dash and the single quote in here, random password. Well, you see that it didn't work anymore. It doesn't say username or password is incorrect because it doesn't get somehow to that part. But let's go back. Now we saw that we added those brackets. We need to correct the syntax, say so, in order to be able to use this payload to log in. So we added an extra bracket that we'll have to close here in our payload, and then use the same or one equals one that is always true. So I'm going to put now again random and login, and voila, now we are logged in again, hacker, and this whole payload set as user. And now the statement executed is this one. You see, select all from users where username equals hacker, and here we close the bracket in order to not have a syntax error. Like after or one equals one, always true, and this whole part ignored because it is seen as a comment. You're logged in again with this new payload. Again, as I said, it's a lot of guessing and experience, to say so, and trial and error. When it comes to SQL injection, you see how a small change can modify the payload needed to log in, but the SQL statement is still vulnerable. Okay, this was the first example. We're going to check the second one. The second example is related to some products page. Now we have here a login portal as in the previous example, but we're not going to attack this one here. But I want to go back to the Ubuntu server and show you the users I have there. So let's see. Okay, back here. This time I'm going to use the other database for this example. And if I run again the same statement, we see we have here 4 users: admin, bronze, silver, and gold. Again, password for all of them doesn't matter. The ones that are important here are bronze, silver, and gold. Now let's go back to the attacker machine and try to log in with any of those 3, and then see exactly where we are going to apply the SQL injection. Okay, back to the attacker machine. So, and we're going to use user silver and password. Okay, we're logged in. We have this access level server, and if we click on get products, we are redirected to a page where we have a list of products available for silver access. See here silver car, silver watch. This is just I don't know, basic text just for examples. We also have here the SQL query executed behind this interface, executed on the server. We see we have here 3 columns: product name, product description, and product category. And we have here the where clause for product category equals silver. This time, the SQL injection will be applied in the URL. You see here this parameter, product category equals silver. It matches this column here. You see also the where clause, where product category equals silver. I made it like this. I made it with the same name in order to be easier to understand. Normally in real life you might find something different here, and again, as I said, a lot of guessing game and trial and error. The first example I'm going to show you here in this URL injection, to say so, will be to modify the URL in order to obtain also some other products. So we have here this SQL statement, and instead of silver, we are going to put this one, silver, and this single quote, and we are going to put again product category different of silver, and again this time we're going to add those 2 single quotes and this single quote in order to avoid syntax error. If we hit enter, we see now here that we got some other products: bronze car, silver car, gold car, bronze watch, silver watch, gold watch. And normally, if we check the product category, we see that we also have the ones for bronze, this one here, and this one for gold, and this one for gold. Normally, you should see only this one and this one, but with silver access, you are able to check the list of other products. If we go back to the Ubuntu server and check the products table, we are going to see that these are present there. So let's check. Okay, if we select here from products, we see that we have here those six items we were able to retrieve also in the example. Now let's get back to the attacker machine. Okay, we obtain these results by, let's say, guessing the column name that is filtered, product category. But you can also change here, and instead of this, you can put 1 equals 1, like we did before. And if we hit now, you see, we still have them. This is because the select statement is modified, because we altered and added this part, and we see that this one is actually the executed part. So again, products silvery or 1 equals 1. Even though we have this one here too, uh, there are also other rows that are not retrieved. So this one is going to be true, and this will retrieve all the items here. If we go back and check the other statement, we see that we altered here and added this part, and then this one here is ignored, and we have product category equals silver, or product category is different um, from silver. Basically, it will return all the list of products. Okay, and let's try again now, this time with gold, because there are also other things that we can do. We can go even further in our SQL injection, but for this you might need to have some basic knowledge. Okay, um, one other thing that can be done is to abuse the union statement in order to obtain information from other tables. Now, we see here that there are three columns: product name, product description, and product category. One thing that we must keep in mind and take into consideration when we are going to use these union statements is that we must have in the other select statement the same number of columns retrieved as we have here. For us, it's easy because we see there are three columns, but normally it's again trial and error. You start first to see if the basic statement has one column, and in the second one you use one column. If it shows an error, we try with two, and so on until we don't receive an error anymore. At that point, we know that the number of columns we have is correct. So. First of all, let's check that our union can be abused. So I'm going to do this union and select, and no, text 1, text 2, text 3, and we're going to put this one here. Now, we altered the URL, and we see that we got the gold car, gold watch, the results returned from the first statement, from the first select statement, like this one. And the last line with text 1, text 2, text 3 is the result for this select statement. And the results are combined, because that's what union does in SQL. It combines the result of multiple select statements. Now, text 1, text 2, text 3 doesn't really help us too much, because we don't actually have anything to do with this. It's not an useful information for us. But as I said, we might need some knowledge about this. Let's try to get the list of databases present on this server. Now, the list of databases is held in a table called schemata from information schema. So we are going to modify this one here. So we are going to put schema name. We are going to leave text 2, text 3, because even though we need only one column, we must put 3 in order to work to function the union statement to be okay and not throw an error. and we are going to put here from information schema dot schemata. And okay, now you see here the whole list of databases present on my server. We have here MySQL, information schema, and so on, and this one too. These two here are the examples I made. In our case, it is a bit easier because we have a table and it can put several rows, one under the other. But depending on the website you have there, uh, it might not always be the case for a table. You might have, I don't know, a list of block items or stuff like this with some text in them, some attributes for, I don't know, a book. We have author, title, and so on. And you might not see it. I honestly recommend to use the group concat function. You'll see immediately what it does. Concat. And hit again. Okay, and now it concatenated the results from that column in a single column. It really might help you when you are performing SQL injection. And we have this one here. Good. Now we're going further and try to find the list of tables from, let's say, this SQLi dbx2 schema. So we are going to put instead of schema name, now we are going to query a different table, and we're going to put here table name. Again, I'm not guessing this. This is the part where I said you need some knowledge on SQL. And instead of schemata, I'm going to put tables and add the where clause. Table schema equals, and then okay, I have a space here. SQLi db example 2. Okay, now we have this last line here, products and users, and you see again this is the first select statement that retrieved these two lines, and the other one that we shouldn't be able to execute is this one here, and it returns the list of tables present on this schema. We have products, we have users, and we can go even further. And instead of information schema.tables, we are going to check this time the columns. We need to change here table name to column name from information schema columns, and in the where clause we are going to add another step and say table name equals users. Okay, now we got the structure for the table users. Again, see here, this is the second statement that is executed where we shouldn't be able to retrieve data from, because we're not supposed to have access to this part. Now we see here that we have three columns: user ID, username, and password. There are three columns to match the three columns we have in the normal display for the products. In a real situation, you might have 4 or 5. It depends. And you can select only 3 of them, but you can run multiple statements and merge the data after based on a primary key of that table. So we're going to do this time something different. We are going to select, instead of these 3 items here, we're going to select user ID, username, password. And now we're not going to use information schema.columns because we want to use SQLi db example2 dot users, and we don't even have to add these where clauses because we want to get all the users. And now we hit enter, and we see here we have the products, gold card, gold watch, this one here, and then with this select statement, we're actually able to retrieve the list of username and passwords from the database. This is just an example. Normally, the users and the password of the user is not stored, is a hash, and this whole stuff worked because the user that I used behind is a user which has access to everything on the database. But you got the point. You can abuse this union in SQL injection and get access to info that you shouldn't. This was my second example. Guys, this was my demo. You were able to see how you can use SQL injection to exploit web vulnerable application. I hope you enjoyed and you learned something from it. And if you got so far in the video, I want to thank you for your for the time you took to watch my video. If you enjoy the content I do, hit the like and subscribe button. Let me know in the comments what you like and what you didn't. See you next time. Bye bye.